Hey everyone, we're back again with another lesson, and this time we are going to do a KCL example. Okay, so if you guys remember from last time, we said that KCL is the sum of the currents equals 0 into or out of a node, and we have a specific convention that we want. We have a current. Our currents will be thought of as going out. So I1, I2, and I3. So let's look at this. So we're trying to find the currents here, here, and that's it. Okay? So using KCL, how are we going to do this? Well, first of all, can we figure it out here? Well, let's see. We have, so all of this guy right here, all of this is 3 amps going down this way we're given the direction of the currents. Okay, so we have to follow. If the problem gives you the currents, then you're going to have to stick to it. Can we figure out and if it's unknown, then we can go ahead and pretend that they're going out. But can we figure out one of these currents from just one variable? Not variable, one constant. No, we can't. We just get x plus y equals -3. We can't apply KCL here, where we do the sum of the i's. So instead, let's go ahead and look for another node that we can check out. Let's try this one. And I'll just use black. So let's see what's happening here. Well, we have 4 amps going in this way, 2 amps going in this way, and 3 amps going this way. We have one unknown, and we're going to call it positive. So let's set up our sum equation. Okay, so let's see all the ones that are going out. This one is going out, this one's going out. So these guys are positive. So we'll do 3 plus, and I'll call that question mark x. Okay, now what is going into the node? Well, 2 and 4. I said that backwards, oops. So -2 minus 4 equals 0. Now let's solve for x, and that's a positive 3. So we know that this guy is going out of the node. Okay, now we still need to find this guy right here. So that guy's not unknown anymore. So how are we going to find this guy? Well, same thing. We've got 4 amps going that way, 2 amps going that way. We have 3 amps going this way, and we have 3 amps going this way. Now, we can either solve it from this node here or this node down here. And you'll notice that we get the same thing. So let's do this node down here first. Sum of the i's, we have -3 minus 3 plus x equals 0. X is equal to 6. So this guy right here is 6. And we can actually verify that with this node right here. So we have 4 amps going out, 2 amps going out, minus 6 equals 0. So we know that KCL is satisfied, and we found that the current in this branch right here is 3 amps, and the current in this branch right here is 6 amps. Okay, so here is another example. So it looks a little more complicated, but it's the same principles. So let's start with easy pickings first. So I'm going to start with this one right here, because we have one current going inward, one current going inward, one current going out, and then one that we don't know. So let's set up our KCL of that. and we get x is equal to -1. Now, it's negative. What does that mean? Well, remember, all currents going into a node are negative. So, our current will be 1 amp going into the node. And you could probably just, like, reason about it. If this guy comes in with this guy, and there's only one way to go out, their currents are going to add up, right? Now that we have this guy right here, we can solve for this guy right here. So I'm going to go ahead and do that. Once again, -2. Oh, sorry. I did my math wrong. +2. And I think you get the gist here. You can actually do this one in your head. 5 and 2. 5 and 2 add up to make 7. Because you got 2 going into the node. To cancel it out, you need a 7. Let me write that a little better. There you go. And check if we have everything. We're missing a few more. One right here. So once again, we have one guy coming in, that one guy coming out. So think about it like how much of this guy is needed to produce that guy that way. 2, right? 2 amps. Now, don't be fooled here. This is still a node, okay? And soon we're going to learn that it has the same voltage across these, but we don't know that right now. But this guy, yeah. So let's go ahead and figure that out. We have 1 amp here, 1 amp right here, and then we have these guys coming into this node right here. So we are going to get 5 amps here. And now we can solve this guy right here. And we have 5 is split up into 1 amp and 4 amps. And see if that works. We have 2 and 2. And so 4 goes into here and splits up 2 and 2. And then if you go here, we have 2 and 1. They combine to make 3. And then 3 and 2 combine to make 5. And then we're already there. And then we got 5 and 4 splitting up to 1. And then we got 2 and 1 combining to get 3. And then we got 3 splitting up to get 1 and 2. And then we got 5 right here and 2 splitting up or combining together to make 7. And then from here we have 7 splitting up from 2 to 2 and to 5. And that's it.